All right. Good morning, guys. How are you guys doing today? You get to listen to me even though I'm not here. Yay! All right. So, hopefully, you've had a chance to get your planner filled out and then be working on your ballerina, which was IXL. Today, what we're going to be doing is we're going to be learning about the greatest common factor. So, there are two vocabulary words. So, in your notebook, you will have a chance to write these down. I'm just going to go through them. Once I get through them, you can pause the video, you can get them written down. There is an example after the two words. So, our first vocabulary word is common factor. So, a common factor is a factor that two or more numbers share. So, if I'm finding the factors of 6 and 10, I would list all the factors and then I would have to see what they have in common. Now, with that too, you might be able to find the greatest common factor. And if I had 6 and 10, I would have to find the biggest number or the greatest number that both of those numbers share. So, an example of that would be if I were to find the greatest common factor of 18 and 30, what I would do is I would list all the factors of 18. Then I would list all the factors of 30. I use the blue highlighter there to show the ones that they have in common. And then the purple one shows the one that is the biggest. So 6 is the biggest number that both 18 and 30 have in common. So once I listed them out, the common factors were 1, 2, 3, and 6, with 6 being the largest. So again, you can pause the video and get those written down along with the example. So what we're going to be doing today is there are 3 different ways to find greatest common factor. You can list all the factors if you're really good at those multiplication facts. You can use the factor trees with prime factorization that we learned last week. Or you can use division ladders, but this one is going to have a little bit of a twist compared to what we did last week. So the first way that I could find the greatest common factors is if I'm really good at my math facts, I can use the divisibility rules to find all the factors. So I know that 6 is an even number. So besides 1 times 6, I know that it's even, so I know that 2 can go into it. So 2 times 3 would also get me 6. Now I had to sit here and think, is there any other way that I can get to 6? There's not. So my factors would be 1, 2, 3, and 6. Now I had to do the same thing for 21. So I know, again, that 1 times 21. It is an odd number, so 2 does not work. When I add 2 plus 1, I get 3, so I know that 3 can go into it. So now I had to think, what times 3 gets me 21? And that would be 7. Now, 4 does not go into it because it's not even. 6 does not. Does not end in a 5 or a 0, so those wouldn't go in. So I think I have found all of my factors. So the factors for 21 would be 1, 3, 7, and 21. Now what I need to do is I would circle the common ones. So 1 is common, 3 is common, and that is it. So now if I look at 1 and 3, the greatest common factor would be 3. So what I'm going to have you guys do is you can pause the video and you can see if you can find the greatest common factor for 24 and 54. Trying to list all those factors. Now, if you are one where finding factors is not you're using your multiplication facts to find the factors is not your strong suit, you can always use factor trees. So last week we used the factor trees to find the prime factorization. You can use that to help you find the greatest common factor. And this is how it's going to work. So again, I'm going to go through the example. You can watch it and then pause the video to write down the example. So if I have 27 and 36, I need to find the greatest common factor of both those numbers. So I would start with finding the prime factorization. 27 is odd, so I'm going to start with 3. 2 plus 7 is 9, so I know that 3 will go into it. So 3 times 9 gets me to 27. 9 is a composite number, so I know that I need to factor that again. So 3 times 3 would get me 9, and 3 is our prime number, so I have 27 all factored out. So the prime factorization would be 3 times 3 times 3. Now, for this purpose, I would not use the powers of 10 because it's easier to see all the numbers laid out, and you'll see why in just a minute. So now on to 36. It's an even number, so I'm going to start with 2. Half of 36 is 18. 18 is still a composite number, so I'm going to split it in half because it is an even number. Now half of 18 is 9. 9 is still composite. And if I look over at my 27, I know that 3 times 3 would be my 2 prime numbers. So again, I need to write this out from least to greatest. So I'd have 2 times 2 times 3 times 3. Now that I have the prime factorization, I'm going to find the common factors. So since 27 was odd, I know that 2 is not a common factor. I know that they both have a 3 and they both have another 3. So what you need to do is once you find the common factors, you need to multiply them. So since 3 is in common, I'd write down the 3. And now they have another 3 that's in common, so I'd write that down. Now there's nothing else in common, so I'm going to multiply the numbers that they have in common. So 3 times 3 is 9, which would make that the greatest common factor. Now, on this next example, you can give it a try. See if you can factor out the prime factorization and find the greatest common factor. You can always go back in the video and rewatch the example, or if you have it written down in your notebook, you can do that also. The last way to find the greatest common factor is to use a division ladder. Now, I like this way the most because I think it is the easiest way. So what you're going to do is you're going to start with your division ladder. This time you are going to put both numbers in that division ladder. So what you are going to do is you have to look now at 14 and 28. I know that 2 goes into both of them. So half of 14 is 7, and half of 28 is 14. So now I'm going to go down here, and I know that since 7 is prime, but 7 can go into 14, 7, now 7 goes into 7, and we're left with 1, and then 7 goes into 14 2 times. So now down here, I am left with my 2 prime numbers, so I can stop. Now, these numbers on the bottom, I am not going to use because these numbers, 1 goes into 7 and 14, but 2 does not go into 7, so these ones on the bottom are not common. They do not go into both of those numbers. But the numbers along the side here are the common factors, and those are the factors that you're going to multiply. So 2 can go into both, and so can 7. So now when I multiply them, 2 times 7 is 14, and the greatest common factor for 14 and 28 would be 14. Now, I'm going to try this one more time, another example, just to let you